Hello, I'm James Ingram. Welcome to the trainprogramming.com video and web page, which is the O Gauge part of the AutoControls-dot-org website, which contains automatic control demonstrations for N, HO, SO, and large-scale trains. In this video, we'll show you some fun, simple DCC automatic control programming experiments that you can do with your O Gauge trains using a simple DCC programmable model train controller, which controls just about all digital trains from tiny Z gauge all the way up to large scale from just about every manufacturer in the world. In this video, we'll show you excerpts, that is to say small pieces, of about 9 different videos. We'll show O Gauge demonstrations if we have them. A few demonstrations will be in other scales, but would work the same in O Gauge. Please ask yourself if this is something you might want to get your grandkids involved with, as it combines both very simple programming and O Gauge model trains, which we think they might find interesting. I've read in train magazines where some people take O Gauge trains into an elementary school and do a demonstration for the kids. We could have the elementary kids use one of these DCC programmable controllers to do some simple programming with the trains. If they had a homework assignment, they could go home and do the same experiment using their own trains at home. In the last part of this video, we'll actually demonstrate a simple programming experiment using an O Gauge locomotive by typing in about 6 simple commands to start and stop a train. To see the complete videos shown in this excerpt and shown in this compilation video, you can use the links below on this video or on the documentation page at AutoControls.wordpress.com, or use the playlist on the AutoControls.org homepage. Thanks for watching. Here's the latest video number 833, part 3 of 3. This is sort of a hybrid video. It shows 2 Chuggingtons being operated on the outside loop. You can see the red one is running right now, and it'll make 2 loops and stop, and then the blue one will run. And you may notice down in the right here, there's a push button that the kids can actually use to push to start the system up. Now you see the blue train running on the inside, and as I mentioned, these Chuggingtons don't have DCC decoders. They're analog Locos, but we can control those using relays operated by the DCC system. Again, that's why I called it a hybrid system. Now the inside train will run. And that inside train that's running right now, that's an MTH Proto 3 loco, and it's running on DCC. So this makes a complete run, and then like girl just push the button to start it up again. So it makes a complete cycle. Then the kids can start it over again. Here's a 3-track automatic passing siding in operation. Note this video is fast forwarded ×2. This is a large scale system running LGB trains. Actually, the red engine on the right is a Heartland train, but all 3 of these locomotives have decoders. We don't currently have a 3-track automatic passing siding video in O Gauge to show you, but we're showing you this one done in large scale, and it would operate very similarly in O Gauge versus large scale. push the forward button, the loco will go as long as the button is pushed. It'll stop when the button is released. So again, this is something we could really offer the public on a public display. And whenever that button is released, the locomotive will stop. And likewise, the same thing happens in reverse. Again, if we release the button, the train stops. If we push down on the button, the train will start up again in reverse. And this is set up so it runs speed 6 in the forward direction and speed 4 in the reverse direction. So right now it's running at speed 4. If I push the forward button and hold it down, when it starts up in forward, you can see it's running a little bit faster because it's running speed 6 versus speed 4. Now, if somebody happens to push down both buttons simultaneously, it'll run in the forward direction because it's set up to look at the forward button first, so it will just ignore the reverse button if both of them are held down. I just closed that switch, which grounded input 1, which has the same effect as somebody standing there holding the push button continuously. So these trains will do that operation in a continuous mode. And note the logic of how this works. When that green engine goes past the detector, it honks a horn, and then the controller executes a delay statement which pulls the green train forward to the station, and it'll sit and wait until the yellow train crosses the detector. Note this is our minimum distance past the detector. We have to pull those trains forward of the detector far enough that when the next train comes in, it won't run into the rear of the stop train. And again, that's done by a delay statement. And these will run. Here's video 827, which is similar to the one we just looked at with the 2-train operation, but we've got 3 trains on the track instead. We're using Kato N-gauge Locos, but this would work the same in O gauge. And what happens if you look at the table in the video, the white table the trains are on, down in the far rear right corner, you see that Z-stuff detector again. And when a train crosses in front of that detector, it starts the 2 trains up in the yard, and then it comes in and parks itself, so to speak. We can see now there's 2 trains parked in the yard, and there's a train out on the main line that's working its way toward the detector. And notice what happens when that train crosses in front of the detector. The red Santa Fe, which is in the far left part of the picture, that'll start up. Here we go. We're getting pretty close to the detector. You'll see that change from green to red. And then the relay contact will close. The train controller will start those 2 trains in the yard up. You can see the one that crossed the detector slowed down. It's working its way toward the station to park itself. The one in the far rear is moving up to the front of the yard, and it'll stop just about now. You can see the 2 trains in the yard have now stopped, and that's Santa Fe Diesels on the main line. Now the same thing will just keep repeating when that crosses in front of the detector. Again, the 2 trains in the yard will start up. So here's a very stable way of running 3 trains on the same track, again using just a single detector and no blocks. We'll watch one more train go past the detector. The detector went to red. You can see the trains in the yard. I'm going to move back here to get closer to the speaker on the camera. Now when I push the forward button, it'll cause that train to move forward. And if I lit up on the forward button, that train will stop and it won't go anywhere until another button is pushed. If we push the reverse button, it'll cause the train to back up. And again, it'll only back up as long as the button is held. The idea is sometimes on public displays, kids actually enjoy something that they can actually operate it, even though it's not really complicated. It could be simple like this, but they can actually operate it and move the train themselves. So, and this thing is programmed so that it won't go off the ends. I'm going to push the forward button and hold it, and when the camera picks it up, that detector will change from green to red. And when it does that, it will close a relay, and the mini panel knows that the train arrived, and again, it won't allow the train to go any further. It will just ring the bell. Like if I hold the reverse button down, we just get a bell ringing. And again, we can't go reverse at this point, but we can go forward. When I push this button here for the public, that'll start these trains up. And this engine here will go down to the engine part. When it crosses this detector, that detector will change from green to red. And that'll send the controller the signal to stop the train. Now it'll wait about 5 seconds, and then it'll start this engine up and bring this engine down. This is running on a time delay. It's running for about 13 seconds and stopping. Since there's no detector, it's using time delay. There, it stopped it. Now the controller will wait about 13 seconds, and then it will back this one up, and you can see it started going back. And when that train gets back to this detector, it'll cross that infrared detector, which will send the signal to the controller that that train is there and will stop that train. Now that'll wait about five more seconds, and then it'll start this train up. And I think we're running at about a 12-second time, and we'll back this train up about 12 seconds, so it parks up in here and stops it. And now we're back where we started, and those two trains will sit there and wait again. And then when they'll sit there and wait for however long, an hour or whatever, and then again when somebody pushes that button the second time, they'll start repeating the cycle. We'll push the start button.
Looks like we've got a Fwd on the way.
You can see the detector went red. Now it's back to green. When that detector went red, it started executing a time delay that'll position that white locomotive at the far end of the track. It's executing about a 27-second time delay. Now the first engine stopped. You can see the second engine's in motion. And it'll just keep going until that engine crosses a detector, which you can see it'll go to red in a minute. There it did. Now the mini panel, that is to say the controller, it's executing an 18-second time delay to position that green engine down in the location where we want to park it. Now that engine stopped. Now the third engine started up, the yellow engine, and that'll proceed until it crosses a detector. They just run until they get to the detector. There's no measurements being made, but once they cross a detector, then the mini panel starts executing the time delay to park the locos in the proper position.
We're ready to go.
That one, the yellow one, it'll run that one for 11 seconds. And again, you can see they park approximately where those white pieces of cardboard are. As I mentioned earlier, those white pieces of cardboard indicate the approximate parking positions of the locomotive. Now it did a 7-second time. This demonstration is fast forwarded 500%. The real-time video is over 20 minutes long, so we speeded it up as an overview. We'll show the real-time video clips at the end of this movie. What we're using here is an NCE PowerCab for power and an NCE mini panel for control. We've got 6 Bachmann N-gauge DCC Peter Witt streetcars running on Kato unit tracks. And what we've got is a simple system here requiring no blocks in the track, just 2 detectors. Let's talk about the logic for a minute. We run 1 car at a time and we park at a specified distance downstream of the detector. And we're using time delay from the moment the locos pass the detector, I should say streetcars. We can't specify distance, but we can specify time past the detector, and the distance is pretty consistent because the cars run a fairly consistent speed. Once in a while you'll see the cars bump, but it's at a real slow speed so they don't derail or anything. Our speed we're using is speed step 18 on the main line and speed step 12 in the yard. Now we've got to use 2 detectors, so 1 detector is going to be clear for the incoming cars. Let's talk about the detector. What we've got here is an NCE PowerCab hooked up to a loop of O gauge track with an MTH Proto Sounds 3 locomotive, which you can see sitting back in the rear. First thing we should mention is NCE recommends you do not use these power cabs on O gauge like I'm doing, because at approximately 2 amps and 14 volts, it's not a high enough voltage or high enough amperage to really seriously run O gauge. But for these little demos I'm doing, we can get away with it because it's we're running slow speeds, lightly loaded. But fully loaded, these engines can pull over 3 amps. Just keep that in mind. I mentioned earlier, NCE says not to use this power cab on O gauge like you see me doing here, against their advice. And somebody asked, well, what do you use? They have what they call the NCE, I believe it's Powerhouse Pro systems, which are 10 amps, and that's what they really recommend for serious users of O gauge, where you're using multiple locomotives and pulling a lot of cars. Before we do any programming, we'll just hopefully quickly show running this loco manually. You can see that loco hopefully on the cab. It's number 779. In the if you look in the upper left corner of our display, it says this is currently set to 888, and our system is currently pulling 0.18 amps. So what we'll do is we'll go down here and we'll find over here we'll find the select loco button, push that, we'll enter the numbers 779, and we'll push the enter button. And now if we look at our display again, it's selected the loco 779 and we're ready to go. To turn this loco on, we'll use the function 3 key, which is where I've got my thumb here. So if I push that 3 key, you can hear that logo is powering on. And we're going to set it to speed step 3, and I'll use the increase button here. You can see on the lower left of the display it says speed 0. We'll increase that to 3. So now we're running our locomotive manually at speed step 3, and you can see it's pulling about a half an amp, so we're well below our 2 amp maximum. So what we want to do now, let's stop this loco. Stop that loco, turn it off. Next thing we'll do is we'll show how to hook up the programmable controller and how to program it, but this just shows how to run the train manually quickly. Now we'll hook up the programmable controller. Over here it's sitting, you can see, not connected to anything. I call this thing a DCC Programmable Model Train Controller. Its official name is a NCE Mini Panel, but we can use it to automatically control trains. And we'll hook one end of this cord over here, and we're going to plug the other end in over here, and that connects and powers up that controller. And this button on the side is a reset button. If I push this, it blinks the LED, which you can probably see right about here. There's a red LED. When I push this reset button, that blinks at it. That also blinks when it sends a command. But now we've got our controller hooked up and ready to go, and we'll put a small program in it. And incidentally, now we've got this controller connected up. To program it, what we'll do is plug a cab into the programming port, which is over here. So now we've got this connected up for programming, and we can take a look at what's in the different memory locations. And let's go to, we want to review. First we'll back out of this. You can see it gives us an operation to set up, review, or test operation. I'm going to press a 2 for review. And it says review inputs. I'm going to tell it to review input 7 and 8, since that's what we're working with. I hit the wrong number. Let's hit review input 7. And I will hit the enter key. Now it says input 7 step 1 end. End is basically a terminate statement, so that's what the thing comes with when it's new. It's all default. It's defaulted to all end statements, which is basically terminate or do nothing. And if we step through those, I'm hitting the increase button here. We can go to input 7 step 2 end, step 3 end, step 4 end, on the input 8 end, input 8 step 2 end, step 3 end, step 4 end. So there's nothing in these 8 command locations for inputs 7 and 8 right now, but that's what we'll do next, is we'll program some commands in there. Incidentally, this is an old cab I'm using. It's about 22 years old, bought in the year 2000. You can see it doesn't say NCE, it says North Coast Engineering, but this stuff is considered one of the best, if not the best, DCC system on the market. Very rugged, very reliable, very user-friendly. If that's not enough, it's made right here in the United States, in Webster, New York, which is a suburb of Rochester, New York. Now here's the program we want to put into this controller, and this sometimes scares people when we say programming, but remember, what we're going to ask ourselves is this something we could demonstrate and have elementary school kids do? That's really the objective, to get some of these into programmable controllers into elementary schools, possibly. So we're asking ourselves, is this something an elementary school child could do? We're using inputs 7 and 8. And the inputs are basically our locations. Think of this as like a Walmart for commands. We've got aisle 7 and aisle 8 in our Walmart, and each of these aisles has 4 shelves, so we can put commands in each 4 shelves on aisle 7 and 4 shelves on I8. They call it inputs and steps, but basically memory locations. First thing we'll do is select Loco 779, because we have to tell the system what Loco we want to command. And here's the actual things we punch in to program it. You don't need to worry about these now until we actually start pushing buttons. But this selects Loco 779. Then we say speed forward 3. That tells it to go forward at speed 3. That's what we were running it a minute ago. Then we say delay a quarter second times 40. That's 40 times a quarter, which gives us a delay of 10 seconds. And then we say speed forward 0, which will stop the Loco. And all we're doing with this simple program, we're starting the Loco up, running it for 10 seconds, and then we're going to stop it, and then we're going to wait, and then repeat it, and it'll just keep doing that. Now, you could actually do something like this probably with what they call the recorder function that some of the proprietary systems have, but you can go far beyond what we're doing here with this system. But this is just to show you how getting started with the programming is fairly simple. So the rest of our program, we've got it started, we've got it moving at speed 3, and we've waited for 10 seconds. Now we stopped. So now we're going to say delay a quarter second times 24. That's 6 seconds. We're going to delay 6 seconds while we're stopped. In other words, we're going to sit there for 6 seconds and do nothing with the engine stopped. Then it says link to input 7. That just takes it back up to the top here, and it starts a program all over again. So the net result is this program will keep looping, and all it'll do is start the engine up, run it briefly, stop it, and let it sit there for a minute, then it'll start it up again, run it and stop it, and keep repeating. Just a simple demonstration of using some simple programming. Now we've looked at what's in these locations. Now we'll do our actual programming, and I just stepped through these 8 memory locations, and you can go backward. Notice I can go 8.3, input 8, step 2, input 8, step 1, and so on. You can go backward and forward to examine them, but I'm going to push the program escape button, which is down here in the lower left corner, and that takes us back to the top level menu. So now this time we'll push the we'll select setup, which is a 1, so I'll push the 1 button to get the setup menu, and it's asking us again. I'll push a 1 for input. We're working on the input, so we're going to start setting up at input 8. So it's input 7. It's defaulted to input 8, so we'll put in a 7 and push the enter key, which is down here almost off the screen. And in step number 1, I'm going to hit enter to select that. So now we're ready to start putting in information into input 7 step 1. And we're actually going through a bunch of hierarchical menus, but rather than doing that, I'm going to use the shortcuts, which is these numbers in this column over here on the right. So I'm going to put in a 31779. So 3 1, enter Loco 779, push enter. So our first command is entered. The next command will be speed forward 3, so we're going to push a 2, speed value 3, enter, direction forward, enter. So now we're to step 3. We're going to put our delay statement in 51240. So we're going to push the 5, push the 1, push the 2, and push the 40 to tell it we want 40 quarter-second delays. Push enter. So that's done. Step 4, we want speed forward 0. That's our stop command. So we're going to enter 3, 2, 2, 0, forward. So we got our first 4 commands entered. We'll do 2 more. We have our delay quarter-second times 24. That's our stop time. That's going to be a 5, 1, 2, 24. So we'll push the 5, push the 1, push the 2, push 24 to tell it we want 24 quarter-seconds, which is 6 seconds. And finally, the last command we need for this, link back to input 7. That's go back and repeat it. So we'll say 5, 3, 7, link to input 7, enter. And then the last 2 are already have ends in it, so we don't need to do anything there. So we'll push the program escape button down here at the lower left. That takes us better to our top menu. So now we can push 2 for review. And we want to say review input 7. Push the enter key. Now we're at input 7, step 1, select logo 779. So we can go down through this. Speed forward 3. Delay a quarter-second times 40. Speed forward 0. So we've started it up at speed 3 for 10 seconds, and then we've stopped it. That's where we are now. Next command, quarter-second times 24. That's our delay. Link to input 7. So that should be ready to run. So what we'll do, I'll grab the PowerCab, which is what we're actually using to control the engine manually. We'll turn it on. Now you'll hear the sound in a minute. I'm going to toggle the 3 function. You see the 3 come back on. It starts back up. So our engine is turned on. Get it back in sight here. Now we're reviewing inputs. I'm going to push the program escape button here to go back to the menu. Now this time we're going to test operations. I'm going to push a 3, and that puts us into the test menu, and I'm going to say testing input. I want to say 7.
Tell them to close up. We're ready to go.
Okay, we're going to say test input 7. The engineer just told me they're ready to go, so to speak. So now it's executing that test routine we put in. It should run for 10 seconds. Stop the engine, there it goes. And it will delay for 6 seconds. And then it'll start up again, run for 10 seconds. Stop for 6 seconds, delay. And then it'll start back up, there it goes. It'll start up for 10 seconds. So this is probably the simplest train operating program you can put into this thing, but it's just good for a quick demo. I will hit the reset button here. I just pushed the reset button, and that breaks it out of the routine. This program does not have a way to graceful exit. Normally you put that in with toggle switches and statements to check them. Let's turn the sound off using the command station. Okay. But this is a simple program that shows how easy relatively it is to hook this thing up to the system and have it control the train. And notice the only hookup is this wire connecting the programmable controller, the mini panel, over to the PowerCab's panel. And so this thing acts just like another cab on the system. I tell people you can consider this thing sort of a robotic cab that's hooked into your system instead of a person sitting here pushing the buttons. You got this robotic cab, the programmable controller, sending commands over the command bus to control the trains. One more command we should mention here is the wait command. What we're looking at here, this top part is the routine we just demonstrated a minute ago. Start the loco up, run it for a period of time, stop it and wait, and then repeat. If we take the same routine here and copy it down here, but we add this thing called a wait command, this allows us to stop the loco in the same place every time. It's the same as before. We start the loco up, we delay for a certain amount of time while it runs. Now we have the statement, in this case it's called wait until input 16 is ground. Input 16, that could be connected to a reed switch or the relay of a Z-stuff detector or Azatrax detector or some other detector or electric eye. But when the train crosses over that reed switch, this will go to ground, and then the routine will proceed to the next step and set the speed to 0 and then delay for a certain amount of time and then link back to the top and repeat. But this allows us to stop at a certain point every time, like a station, or for running multiple trains, when this statement gets executed after that, we can start the train that stopped up, and the train that just came into the station, we can stop that train, again, for multiple train operation. But this is basically the building block we can do to make all sorts of simple but interesting routines like you've seen in the video excerpts. Finally, there's a skip command we can mention, which is basically a decision-making command. Let's say above this, these steps we've been doing some routine like we talked about a minute ago. We come down to this statement, skip if input 18 is open. That can be typically a toggle switch or a knife switch or something like that. And it takes us one way or the other way depending upon the condition. In this case, if input 18 is closed, it won't skip that statement. It will come to the next statement, link to input 1, and go back to the top and start repeating this routine. However, if input 18 is open, then it will skip the next statement. It'll do something like this, change a status light, and then terminate. That is to say, it'll end the routine. So again, this skip statement gives us a decision-making capability, and this is probably the final step we can use to write these routines, is the wait statement like we talked about a minute ago, and this skip statement. And also to mention, that's an MTH Proto Sound 3 diesel. All of the MTH Proto Sound 3 locomotives can run on the world standard DCC, as well as a proprietary DCS system. And MTH started releasing the Proto 3 locomotives around 2011. So we can basically say all MTH O Gauge locomotives made since 2011 will operate on DCC. And there's a switch on the bottom of that locomotive that you can flip from DCS to DCC. And all MTH Premier locomotives have that switch. And I've been told the MTH Rail Kings had it from about 2011 to 2014. Now that's about a 2018 or 2019 Rail King locomotive, so we had to add the switch to that locomotive. And most of those locomotives do have the slot and even the later lettering, or I should say the labeling, on the bottom of the frame, so you can put that switch in. That is to say, the mounting hole is still there. The documentation website for all this stuff is at AutoControls-dot-wordpress.com, which is part of the AutoControls-dot-org and trainprogramming.com websites. And the video for getting started with this train programming is video number 816. It's called Getting Started with the NCE Mini Panel, which is what we're programming. And that has about 15 experiments similar to what we just did, but starting real simple, like with just blinking that LED using the reset button, and working up through running two trains on the same loop and running a single train point to point.